As SpaceX's Starship Flight 8 roared to life on March 6th, all eyes were on the skies above Boca Chica. The liftoff was flawless, the power of 33 Raptor engines propelling the massive vehicle upward in a fiery spectacle of engineering brilliance. Booster 15 executed its boost-back burn and, in a remarkable feat, was caught by the launch tower's mechanical arms, another step closer to SpaceX's dream of full reusability. But while the booster's recovery marked a triumph, Ship 34's journey took a devastating turn. A catastrophic engine failure led to a loss of control, sending the spacecraft tumbling uncontrollably before breaking apart on re-entry. The fiery debris scattered across the Gulf, triggering safety concerns and regulatory scrutiny. What went wrong? And what does this mean for the future of Starship? Let's dive into the details. A flight of triumph and tragedy. SpaceX's Starship Flight 8 was a mission filled with both groundbreaking achievements and unexpected challenges. On March 6th, the towering 400-foot Starship lifted off in a breathtaking display of power, marking another step forward in the company's quest for fully reusable spaceflight. Booster 15 executed a near-perfect return and was successfully caught by the launch tower's chopsticks, showcasing SpaceX's innovative approach to rapid reusability. However, the excitement was short-lived. Ship 34, the upper stage, suffered a critical engine failure mid-flight, leading to a disastrous loss of control and eventual breakup upon re-entry. This incident not only raised questions about the vehicle's design, but also prompted regulatory investigations. What exactly happened to Ship 34, and what lessons can SpaceX learn from this mission? Let's analyze the key moments and their impact on the future of Starship. The journey of Starship Flight 8. Success, failure, and lessons learned 1. The launch. A spectacle of power and precision. Starship. Flight 8's journey began after multiple delays as SpaceX worked through technical issues and weather concerns. Finally, on March 6th at 5:30 p.m. Central Standard Time, the massive Starship Super Heavy system roared to life, igniting 33 Raptor engines in a fiery display. The vehicle ascended smoothly from Boca Chica Beach, Texas, clearing the launch tower without any significant issues. The first stage, Booster 15, performed flawlessly during its ascent, completing its designated burn. SpaceX successfully executed hot staging, a technique where the second stage ignites while still attached to the booster. This method has been adopted to improve efficiency and reduce unnecessary fuel loss during stage separation. Second booster. 15. A major step toward rapid reusability. One of the mission's highlights was the performance and recovery of Booster 15, an upgraded version of the Super Heavy booster. This booster incorporated several improvements including enhanced avionics and a more powerful flight computer for better control, upgraded power distribution systems to increase reliability, smart battery integration to optimize energy usage. Approximately 2.5 minutes after liftoff, Booster 15 separated from Ship 34 and began its descent. SpaceX tested a new landing profile in which the booster approached from the top rather than from the side, reducing the risk of engine exhaust damaging the launch tower. This maneuver worked as intended, and Booster 15 executed a precise boost-back burn followed by a landing burn, ultimately being caught successfully by the chopsticks, the mechanical arms of the launch tower. These improvements were designed to increase the booster's performance during critical phases of flight. Approximately 2.5 minutes into the mission, Booster 15 successfully separated from Ship 34 and began its descent back to Earth. In a significant achievement for SpaceX, Booster 15 executed a precise series of maneuvers, including a boost-back burn and a landing burn, before being successfully caught by the launch tower's mechanical arms, known as chopsticks. This marked the third successful retrieval of a Super Heavy booster, and only the second instance where SpaceX achieved both a Starship launch and a Super Heavy booster catch in the same mission. The successful catch of Booster 15 represents a crucial milestone in SpaceX's goal of rapid reusability. By catching the booster with the tower arms, the company aims to reduce turnaround time between launches and minimize refurbishment costs. This achievement brings SpaceX one step closer to its vision of a fully reusable launch system capable of supporting frequent missions to the Moon, Mars, and beyond. This marked only the second time that SpaceX had launched and caught a Super Heavy booster in the same mission, proving that their ambitious reusability goals are achievable. The ability to recover boosters without the need for ocean landing significantly reduces turnaround time and costs, bringing SpaceX one step closer to frequent and cost-effective launches. Third Ship 34. A critical failure. During re-entry. While Booster 15's return was a success, Ship 34's journey was far more turbulent. Shortly after stage separation, the upper stage entered its suborbital trajectory over the Gulf of Mexico. However, not long after, troubling signs began to emerge. Video footage from SpaceX's live monitoring system showed an explosion in Ship 34's engine bay, suggesting a catastrophic failure. This malfunction bore striking similarities to Flight 7's failure, where Ship 33 was lost due to a leak in the propulsion system. Potential causes of Ship 34's failure. Several factors could have contributed to the engine failure and subsequent loss of control. 1. Harmonic oscillations in the propulsion system. O. These vibrations might have caused stress fractures in the ship's internal structure, leading to a fuel leak. 2. Propellant line. Rupture. O. The extreme vibrations could have caused a rupture in the propellant supply lines, leading to a massive fuel leak and an uncontrolled fire. 3. Critical Raptor engine failure. O. A Raptor vacuum engine suffered a rapid unscheduled disassembly, RUD, near the center engine cluster, which may have triggered a chain reaction failure, knocking out all three central engines. 4th. Thermal protection system issues. O. SpaceX had deliberately removed some heat shield tiles for testing purposes, which could have exposed vulnerable areas to extreme heat during re-entry. 5. Structural stress on rear flaps, oinpoints. The re-entry profile placed extreme stress on the rear flaps, potentially exceeding the ship's structural limits. With its three center engines offline, Ship 34 experienced off-centered thrust, causing it to tumble uncontrollably. This resulted in loss of orientation and an uncontrolled re-entry, where the vehicle broke apart in the atmosphere. The debris field forced several aircraft to divert from their flight paths to avoid potential collisions. The footage, captured on one of SpaceX's monitors, shows what appears to be an explosion in Ship 34's engine bay. While the video does resemble an engine explosion, it's important to note that SpaceX has not yet officially confirmed the nature of the incident. The anomaly with Ship 34 bears similarities to the incident that occurred during Flight 7, where Ship 33 was lost due to a leak in the propulsion system. Improvements implemented for Flight 8. Prior to Flight 8, SpaceX had implemented several improvements to address the issues encountered in previous flights. Redesigned forward flaps to reduce re-entry heat exposure and simplify mechanisms. Increased propellant volume. The Starship upper stage's propulsion system gained a 25% boost in propellant volume to enable longer flights. Additional vents. Extra vents were added to the aft section of a Ship 34 to mitigate issues encountered on Ship 33 during Flight 7. Extended static fire test. SpaceX conducted a nearly 1-minute static fire test with Ship 34 to test new hardware and cycle the Raptor engines through multiple thrust levels. Despite these improvements, the anomaly with Ship 34 suggests that further refinements may be necessary to achieve consistent success with the Starship upper stage. The data gathered from this flight will be invaluable for future improvements to the Starship system. Objectives of Flight 8. Flight 8 was designed to achieve several objectives that were not met during the previous test flight. 1. Payload deployment. For the first time, Starship attempted to deploy a payload consisting of 4 Starlink satellite simulators. Second, re-entry experiments. The mission included multiple re-entry experiments aimed at gathering data for future missions where the upper stage would return to the launch site for recovery. Third, Raptor engine relight. A single Raptor engine relight in space was planned to test the vehicle's ability to perform orbital maneuvers. Fourth, heat shield stress test. SpaceX intentionally removed some heat shield tiles to assess the performance of the thermal protection system under stress. While the full extent of these objectives' completion is not yet known due to the anomaly, the data gathered from this flight will be crucial for refining the Starship system and addressing the challenges encountered during the mission. Regulatory environment and safety review. The launch of Flight 8 came after SpaceX completed a comprehensive safety review and received approval from the Federal Aviation Administration, FAA. The FAA issued a license modification for Flight 8 and beyond, allowing for certain operational changes, such as the installation and removal procedures for the flight termination system. It's worth noting that while SpaceX received clearance for Flight 8, the mishap investigation for Flight 7 was still ongoing at the time of launch. This highlights the complex regulatory environment in which SpaceX operates and the company's ability to address safety concerns while continuing its ambitious test program. The aftermath. FAA investigation and SpaceX's next steps. Due to the failure and resulting debris field, the Federal Aviation Administration, FAA, has launched a mishap investigation requiring SpaceX to analyze the failure before they are allowed to fly again. This means that both Flight 7 and Flight 8 investigations are ongoing, delaying future launches. SpaceX engineers now face a challenging task, determining the root cause of the failure and implementing design improvements to prevent a similar incident. Despite the setback, the data collected from Flight 8 will be crucial in making Starship more reliable and reusable in future missions. The bigger picture. Progress despite setbacks. Despite the failure of Ship 34, the mission was far from a total loss. The successful booster catch was a major win for SpaceX's reusability goals. Moreover, the failure itself is valuable. Each mishap helps SpaceX refine Starship's design. The Starship program is an iterative development process, meaning that every test flight brings improvements. As SpaceX works to solve these issues, the company remains committed to achieving fully reusable space travel. The future of Starship. What's next after Flight 8? The failure of Ship 34 during re-entry was a significant setback, but it also provided critical data that will help SpaceX improve future Starship designs. Despite this, the successful hot staging, booster catch, and overall mission progress demonstrate that SpaceX is steadily moving toward making Starship a fully reusable spacecraft. 1. Lessons learned from Flight 8. Every failure brings valuable insights, and Flight 8 was no exception. SpaceX engineers will now focus on several key areas of improvement. Engine reliability. The Raptor vacuum engine failure suggests that either the engine design or its thermal shielding needs further refinement. Future versions will likely feature more robust engine mounts and additional thermal protection to withstand re-entry stress. Structural enhancements. If harmonic oscillations cause the propellant line rupture, SpaceX may need to redesign the internal plumbing and reinforcements in the engine section. Thermal Protection System, TPS. Optimization. The deliberate removal of heat shield tiles on Ship 34 may have exposed vulnerabilities. Future Starships will likely incorporate an upgraded heat shield, ensuring better resistance to extreme temperatures. Landing burn adjustments. Ship 34's engines failed before the final landing burn, meaning SpaceX must improve engine restart procedures during re-entry. 2. The impact on SpaceX's timeline. The FAA's ongoing mishap investigation means that Flight 9 and future Starship launches will be delayed until SpaceX implements corrective measures. However, history shows that SpaceX thrives under pressure. The company has bounced back from failures before, iterating rapidly to create better spacecraft. Flight 9 will likely feature a more advanced design. Elon Musk has hinted at new heat shield materials, a revised engine configuration, and upgraded flight software for the next test. Crewed Starship missions are still years away. NASA and private customers, including Dear Moon and Polaris program, are closely watching these test flights. Until Starship consistently survives re-entry, SpaceX cannot fly humans aboard. 3. Why these setbacks are normal. In spaceflight, SpaceX's test and fail approach is fundamentally different from traditional aerospace companies like NASA or Boeing. Instead of spending years designing a perfect spacecraft on paper, SpaceX launches real prototypes, gathers data, and iterates rapidly. This method has proven highly effective in previous SpaceX projects. Falcon 9 suffered multiple early failures, but it is now the most reliable rocket in history. Crew Dragon had a catastrophic explosion in 2019, yet it went on to become the primary spacecraft for NASA astronauts. Starship's first flights ended in massive explosions, but SpaceX quickly learned and improved upon each failure. The same iterative process will ultimately lead to a fully functional Starship, capable of carrying humans to Mars and beyond. The bigger picture. Why Starship matters. Starship is more than just another rocket. It represents a revolution in space travel, with implications that extend far beyond Mars colonization. Reducing spaceflight costs. By making both stages of Starship fully reusable, SpaceX could cut launch costs by 100 times, making space travel as affordable as air travel. Lunar exploration. NASA's Artemis program depends on Starship HLS to land humans on the Moon. Each successful test brings that reality closer. Interplanetary travel. Elon Musk's dream of a self-sustaining Mars colony relies on Starship becoming a reliable mass transport vehicle. Commercial space travel. Private missions like Dear Moon and Polaris are set to take civilians beyond Earth, opening a new era of space tourism. 5. Conclusion: a step closer to the future. While Ship 34's failure was disappointing, the successful booster catch and hot staging test proved that SpaceX is making real progress. Every test flight, whether a success or a failure, pushes Starship closer to becoming the most advanced spacecraft ever built. With Flight 9 on the horizon, SpaceX engineers are already working on solutions to the problems encountered in Flight 8. When Starship eventually succeeds, it will change space travel forever, paving the way for a future where humans are no longer confined to Earth. The road ahead is long, but if there's one thing SpaceX has proven, it's that failure is just another step toward success.